I'm Anil Kumar. Welcome to my series of learning and enjoying mathematics. We'll talk about Pythagorean theorem and Pythagorean numbers in this particular video. So whenever we talk about Pythagorean theorem, we are always looking into a right triangle. So I just made one here on the right side of my page. So let us say this angle is 90 degrees. In that case, the sides of the triangle are always related with the relation a square plus b square is equal to c square. So if this is a right angle triangle, in that case, sum of these two smaller sides square, a square and b square, is equal to that of the square of hypotenuse. Now these two sides are called legs, right? So these are legs and this is hypotenuse. This is also called legs. So legs are shorter sides. So the longer side, which I have named as C in this particular diagram, its square is equal to sum of the squares of the other two sides. So this formula can also be written as C is equal to a square plus b square square root. Correct? You could also rearrange and find the length of smaller sides, writing a as equals to c square minus b square, and then square root will give you what a is, or b could also be written as square root of c square minus a square. So this formula, which is called the Pythagorean theorem, so this is what Pythagorean theorem is all about, can be seen in so many different ways. So as you see here, you could find the third side knowing 2 in a right triangle using Pythagorean theorem. Now this is a very important statement which is converse of Pythagorean theorem. Now it says that if I have a triangle, let's say, let me make a triangle here, and let's say the sides of this triangle are, let's take them as, let's say 3, 4 and 5. Very simple numbers to work with. Then what do we figure out? We say that 3 square plus 4 square is equal to 9 plus 16, which is 25. And that is same as 5 square. Do you see that? So in this particular diagram of a triangle, we found that the three sides, the sum of squares of smaller sides is equal to that of the bigger side. Therefore, this should be a right triangle. So this angle should be 90 degrees. That is the converse of Pythagorean theorem. Perfect. So that is how you could actually see Pythagorean theorem in different ways. Since we have learned all this, let me take quickly some examples. So what I will do here is just draw some right triangles for you. Okay, so it could be in any fashion, correct? So let me draw some triangles in different formations. Now in these triangles, I'll give you sum of two sides, and you need to find the third side. So that is the exercise for you. So let the sides of this triangle could be, let's say this is 25. Let this be 7. Now here I'll give you dimension as, let's say one side is, I don't want to write 3, 4 and 5. Let me write this as 13 and this side as 5. And in this triangle, let's take a side which is, let's say this is 6 for us and this is 10 for us. We need to find the third side. Okay. Now in the first triangle, we are given the hypotenuse. Do you see that? Not the smaller side. So the smaller side should be equal to what? It has to be difference of the squares. That is 25 square minus 7 square, square root. Here also I have given you the hypotenuse. So in this case, the smaller side should be 13 square minus 5 square. Here also I have given you the bigger side. So in this case also the unknown side has to be 10 square minus 6 square root. Now you can use the calculator to find the answers. What you will notice is that these are numbers which are all integer numbers. So you'll find this to be 24 and this number to be 12 and this number is like 3, 4, 5, 6, 8, 10 as 8. So what you find here is that the unknown sides were integer values. So we found this as to be 8, this to be 12 and the other side here was 24. So in all three triangles which I have here, you find integer values. So if you have triangle with right angle and integer values, we call these numbers as Pythagorean triples. You get the idea. So we'll also see how to generate Pythagorean triples, right? You don't have to remember these numbers. We'll see how to generate these numbers. Now let's take a small break. So I'll go for a walk and let's see what we find there. And then we'll continue with some more examples on right triangle and also learn how to generate Pythagorean triples. I hope you find that interesting. I hope you enjoyed the break and the beautiful nature. Now let's continue with our classroom setting. We'll solve these right triangles and use calculator, right? So we'll find the answer to tenths. That means 1 decimal place. So now you need a calculator to answer these questions. Let me write down the questions. We have a triangle. We need to find area of the triangle. So let me write down the sides. I'll give hypotenuse here as 10 and the longer side as, let's say we make it 9. We need to find area of this particular triangle. Now in this case, let me make this, let's say, what is the shortest length of the diagonal? Let's see this. So we'll find length of diagonal. Let the sides be, let's say this is, let's say 20, and let this side be, let's say 15. Okay. In this case, we need to find the length OP. So length OP of this segment, right? So these are 3 questions for you. You can pause the video, use your calculator, round answers to tens, and then look into my suggestions. Now let's begin with the very first one. Area of the triangle is what? Is half of base times height. Now we are given all this as right angles, right? Now, base is known to us as 9 units. Height, we don't know. How do we find this height? So let's say height is h. We could use Pythagorean theorem to find height. So h is equals to square root of 10 square minus 9 square. So let's use the calculator to find this value. So we get square root of 10 square minus since it is the smaller side, right? So that gives you square root of 19. So now the area is how much? To find the area, we need to multiply half with the base of 9 times square root of 19, correct? So let's do it. So we already have square root of 19. We'll multiply this by 9 and then divide it by 2. So we get the answer in decimals as 19.61. Rounding to one decimal place, we get this answer as equal to 19.6 and unit square. So if no units are given, so we say unit square. So we found the area as 19.6 unit square. Now in the second case, let's try to find the length of the diagonal. Let's say D is the length. So D is the longer side. So we have to add the squares of the other two and then square root it. So we get 20 square plus 15 square square root. So that is square root of 20 square plus 15 square, and that gives you 25. So we get our answer here as 25. Correct? So that is the length of the diagonal. To find the length OP, it is also like a diagonal, right? Or hypotenuse of a triangle. How do you get the triangle in this case? Well, from P, if I drop a perpendicular, then the height of this perpendicular is the y value 6, and this is the x value 5. So the length OP is equal to what? So we can say that OP is square root of 5 square plus 6 square. So let's use the calculator once again. We have square root of 5 square plus 6 square, and that is equal to square root of 61, and in decimals it is 7.81. Rounding to one decimal place, we get 7.8 units. So that is how you could actually use your calculator and get the answers to one decimal place by solving right triangles or even rectangles, finding their diagonals. So these could be some applications. Now let's look into the method of generating Pythagorean triples. Now let's get back to Pythagorean triples. Here is a very interesting method to generate these triples. Now, what are Pythagorean triples? Basically, we are looking for three integers which could be sides of a right triangle. So if we get a set of numbers which could be sides of right triangle, we call them Pythagorean triples. So if this is the right triangle and let's say the numbers are A, B and C, in that case A square plus B square should be equal to C square for this triangle to be a right triangle. That's the whole idea. Now how do we generate these triples? So here are some steps to follow, easy steps to follow. First, let's begin with number A. So A is equals to an odd number. So you could take any odd number greater than 1. For example, you could give a value of A as equals to twice a number and then plus 1, where n is greater than, let's say, 1. It could be greater than 0 also. Anyway, so let's say n is greater than equal to 1. Is it okay? Okay. So if you say n is 1, so let me make a table here, right? So if I say that n is equal to 1, in that case, what is the value of a? In that case, I can write the value of a as 1 times 2 is 2 plus 1 as 3. So get a value of a. The next step is find a square minus 1 by 2 and a square plus 1 by 2. Okay, so a is 3. So what is 3 square? 9. 9 plus 1 by 2 gives me 4, right? So here what we get here is 3 square minus 1 by 2, and the other number is 3 square plus 1 by 2. So you'll find that these are the other two numbers, B and C for you. So if you calculate 9 minus 1 is 8, you get 4 here, right? So what you get here is the set of numbers which are 3, 4 and 5. Do you see how we got the first set of numbers? You could continue this, right? So for n equals to 2, the value of a will be 5, correct? What is 5 square minus 1? Let's do 25 minus 1 by 2 is 12, and 25 plus 1, which is 26, divided by 2 is 13. So the other two numbers are 12 and 13. Do you see that? Now, if I take n as 3, then a is going to be 7. Now 7 square is 49. So 49 minus 1 by 2 and 49 plus 1 by 2 are the other two numbers. So 50 by 2 is 25, you know. 1 less than 25 is 24. So this number is 1 less. So you could easily get a series of numbers. You get an idea, right? So if you do for 5, in that case, a will be equals to 5 times 2, 10 plus 1, 11, for example. So the number will be 121 minus 1 by 2 and 121 plus 1 by 2, right? So 122 half is 61. So we could get this as 61, this as 60. So likewise, you can continue the series. Perfect. Now somebody wants to know how to do for even numbers. So times it by 2. So if I times 2 by 2, I get 4, 10. You are getting my point? So times each number by 2. So don't forget about this. Times these triple by 2. So if I double this, then I get the other numbers, right? So if I double this, I get 5, and this is 10, 24, and 26. Here, 3, 4, and 5, if I double them, I get 6, 8, and 10. Does it make sense to you? Correct? So that is how we could also get the even numbers for a triangle triples. You get an idea, right? So that is how we could generate our series. So what will be number for 9? Well, 9 square is 81. So take away 1 will be 80. Half of that is 40. 41, for example. So I hope now the method is clear to you, and that is how you could generate infinite number of Pythagorean triples. Isn't that cool? So I hope you've learned a good technique. With this technique, you can actually solve many multiple choice questions even without using calculator. I hope that helps you in future. If you like and subscribe to my videos, that will be great. Share my videos with your friends and keep posting your queries. Thanks for watching and all the best.